Hello, everyone. Hello, Karina.
Hello.
You
Hello.
look, you look so pretty in your school dress. Hello, Alice.
Hello.
Hello, Max.
Hello.
How are you today?
I'm great.
That's
I'm
great. I'm cold. I'm really cold. All right, so today we are going to learn about stars. What do you know about stars? Can you tell me one thing that you know about stars? Yes, Max.
Really hard to explain because I know a lot about stars.
Okay, so tell me one thing you think is interesting.
That one thing that is really interesting. Uh,
What color are stars?
some are white, some are yellow, some are red.
Very good. You are correct. Good job, Karina.
And some are also blue.
That's right. All right, so do you know why it's blue?
Because it's very old.
Close, close. Alice, what do you like about stars?
I like about stars that um, 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 but they are very beautiful.
That's right. They can be. So we are also going to watch a video about telescopes because there are really big telescopes that are so big they fit on top of mountains just so they can see what is up in the sky. The closer you get to the sky, the further that you can see. Yes, Alice.
I have a telescope, but it's little.
That's okay. If you are in an area, if you have a clear sky, next class we are going to learn about constellations, and part of your homework is to find a constellation. And if you have a telescope, you can use it.
But I have a sky with clouds.
So it will be very exciting to do that. But first, let's talk about let me share my screen with you guys. All right, so first, there are many stars out in our galaxy. Now, let's review a little bit. What is our galaxy called? Max.
The Milky Way.
Very good. The Milky Way. Now we talked about how it got its name, and a lot of the stars and the stories come from Greek mythology. So mythology is where there's stories that have a moral to it, there's a point to it, but they're not real. So it's just something very interesting to learn. So let's talk about what are exactly stars. All right. Max, can you read in English?
Yes.
Okay. Do you want to read? Let me get my thing. Would you like to read from here to here?
Yeah.
Okay, great. You can start.
What are stars? Many of the imagines of our solar system show the planets close together, but they are actually very far away from each other.
Very good.
Stars are
Huge.
huge, fiery balls of gas. They co- uh, co-
Closest.
closest star to Earth is the sun. If you could travel at the speed of light, it would take you a little over 8 minutes Earth to reach the sun.
However,
However, the sun is very far away from Earth, over
that's a big number.
100 150
50 million.
millions kilometers.
You don't have to say that one.
93 million
Miles.
miles. The next closest star is so far away from Earth that it would take you over 4 years to reach it. If you could travel at the speed of light.
Excellent job, Max. Oh, good work. You read very well in English. Good job. That is very tough to do, and you did a great job. The only word you missed was this one, which is images. Images are like pictures. So many pictures are images. Very good. I'm very proud of you. Yes, Alice.
Can I read the last of this?
Sure. Yes. Wonderful.
The
You
small,
can go ahead.
the small points of light we can see in the sky at night are usually stars. Some of them look some of them look just like large stars, but they are really planets that have the light of the sun reflecting off them. On a clear night, we can see about 5,000 to 9,000 stars in the sky. There are billions of stars in our galaxy, so we see only a tiny fraction of stars with the naked eye. The darker it is around us, the more stars we can see. If you are standing at night in the middle of a city full of lights, you won't see nearly as many stars as you would see in the country away from the lights.
Very good. Excellent. So really, yes, Alice?
And naked eye, it is without anything, without any telescope.
Excellent. Yes, very good. You are so smart.
Что, зависло?
Teacher Adrian, you're frozen.
All right, so this is just, yes, it's just an average star. What do you see? Can you tell me, what do you see, Karina?
Sun. Sun.
All right, so this is a yellow star. So it does look like our sun because our sun is a yellow star. All right, so what do you think these are? What do you think those are? Alice?
I think it's the fire.
Okay, so usually we also call these flares. Flares. And yes, Max?
It is gas.
It's what?
Gas.
Yes, see, it's all this is just fiery gases. That's the reason why it has a fire look into it, because it's fiery. So it's like it's fire. And then these things are called flares. And sometimes these flares can actually for our sun, when our sun has a flare, it actually affects the earth. It actually does something to our earth. All right, so Karina, are you comfortable in reading?
Yes.
All right, so why don't you start here?
Stars are formed when great
Gravity.
gravity pulls gas and dust
Mhm.
together. A small dust and gas clouds get put together for
Friction.
friction makes the clump heat up. When it finally gets hot enough, the clump
Undergoes.
and a clear reaction that makes the stars shiny brightly. Right.
Very good. Very good. Brighter. So at the end, it has ER, brighter. So it shines brighter. So as the stars are being formed friction is when it does this. Like when you're trying to make a fire, you get friction. And then what happens, Max, when you rub it really hard? What happens to those sticks? What starts happening? Yes, Max.
It is starting to like the fire starts to go.
Yes, a fire starts, and that's what happens when a star is made. I want everybody to get your hands like this and start rubbing really hard, really fast. Do that. All right, now stop when it starts getting really hot. Woo! That's hot. You better watch out, Alice. You might start a fire with your hands. That's what a star does. And as it gets hotter and hotter and hotter, then it has a nuclear explosion, and that's where the star gets its brightness from. All right, so some stars are brighter than others. Can you feel it, Karina? Is it hot? Are your palms hot?
Yes, it's very
You
hot.
did it. Yes.
And my hands are very smelly, and they
Yeah.
smell like some fire with some sticks.
You're going to have, I know you're going to have to wash your hands because, whoo, they smell because they're so hot. So that's what a star does. So I don't think stars smell very good. If they smell like gases and dust makes me sneeze. So they are smelly dust. So did you know the bigger the stars, the brighter they are than smaller stars? But guess what? The big ones burn out really, really fast. They're really, really bright, and then they die. Did you know that stars die?
Yes.
Yeah.
Yes, they die. And what do they turn into?
Into dust.
Oh, close, Max.
Some turn, the biggest turn into a black hole.
That's right. They turn into a black hole. Very good.
The smallest
And what?
turn into other type of stars. And when this type of stars die, there comes another type of stars. And
That's
then it just explodes, and I don't know what.
That's right. You're good. You're doing good. You're on the right track. That's exactly what happens. They turn into a black hole, and then it actually has some type of reaction, and there's a lot of things that are just going on around a star that dies. Just like me and you and a plant and animals have a life cycle, so do stars. Stars have a life cycle too. All right, but stars closer to the Earth appear brighter than those far away. Astronomer referred to the star's brightness as luminosity. So if you illumine something, I'm going to write that word down. Illumine something. That means that you are making it brighter. So if you illuminate something, that means something is very bright. All right. So let's watch a video on telescopes right quick. All right, so let me get that together because I think you guys will love it. Hold on. All right. All right. All right, let me share my screen. All right, so let me. All right. Tell me if you can hear it. Give me a thumbs up if you can hear it.
Mind has always been driven to explore and discover. The desire to learn, see, and know more lives within each of us. In the early 1600s, this drive led several men to experiment with glass lenses and create a device that you could look through and see images magnified up to 3 times their normal size. This device was one of the first steps in creating modern inventions like the microscope and the telescope. Galileo Galilei, a famous scientist and engineer, heard about this new invention and, without even seeing it, immediately began to build his own version. Galileo made significant improvements to the design and was able to achieve magnifications of 20 times an object size. However, while others used these rudimentary telescopes to study the natural world around them, Galileo was the first to point his skyward. An entirely new world was revealed. With his telescope, Galileo studied the moon in detail, noting its cratered surface and phases as it orbited the Earth. He also discovered the rings around Saturn and moons around Jupiter. The telescope, along with its counterpart, the microscope, was pivotal in helping humankind understand that what we see with our naked eye is only a very small part of the world we live in. In the intervening 4 centuries since Galileo's discovery in 1609, the telescope has been refined, reformed, and reinvented, allowing us to peer deeper and deeper into the black expanse of space. Today, you can purchase a relatively inexpensive telescope and see for yourself the same stars that entranced Galileo 400 years ago. However, scientists quickly realized that to see farther into space, their instruments would need to be significantly larger. Over the years, telescopes have evolved from simple handheld devices to huge, complex machines directed by computers. Now, massive telescopes dot the Earth from the Chilean desert to the mountaintops of Hawaii. They are even found in space, orbiting the Earth. Let's take a look at how far the telescope has come by studying 3 of the most famous telescopes in the world. The Atacama Large Millimeter Array, or ALMA for short, is a large group of radio telescopes. Stars, black holes, and other space phenomena give off radio waves, and these radio telescopes allow us to receive these waves and learn more about the stars in the process. ALMA was built in the Atacama Desert in northern Chile at an elevation of 5,000 meters, or 16,000 feet. The high elevation of the area, coupled with the low humidity, is ideal for receiving clear signals. The telescopes are actually mobile and can be moved up to 16 kilometers or 10 miles to be positioned correctly. Working together, they act like the zoom lens on a camera, allowing for beautifully detailed images. Perched atop the dormant volcano Mauna Kea on the island of Hawaii, sits the W.M. Keck Observatory, with its twin telescopes Keck 1 and Keck 2. Located near the equator and at an elevation of 4,145 meters, or nearly 14,000 feet, Mauna Kea makes an ideal location for astronomical observation. Each telescope is housed inside an insulated dome and measures 10 meters or 32 feet across, and weighs an astounding 300 tons. Each telescope utilizes a mirror made up of 36 individual segments, and this mirror can be moved 2,000 times every second, allowing astronomers to cancel out atmospheric distortion. This creates images that are 10 times clearer. Perhaps you've noticed that these telescopes have all been located at high elevations. This is to reduce distortion caused by our atmosphere. Scientists realize that this problem could be avoided by stationing a telescope in space, out of our atmosphere completely. Let's turn our attention to arguably the most famous telescope in the world, the Hubble Space Telescope. Launched into low Earth orbit in 1990 as one of the first space telescopes, the Hubble telescope is still operational today. It weighs in at 11,000 kilograms or 24,000 pounds and has the length of a large school bus. It is powered by two 25-foot solar panels, but it uses surprisingly little power, just
I can't hear.
Me too.
of data each week. That's as much information as you would find in a stack of books 1,000 meters or 3,600 feet tall. Humankind's fascination with exploration and discovery remains undiminished today. Like Galileo, we are driven to learn and grow and improve. There is an infinite universe out there to study, and who knows what new discoveries await us.
All right, so hi, Danya.
Hello.
I'm so glad you could make it. All right, so let's look at some pictures of some stars, okay? Let's look at this. If you look, what do you think this is?
Star.
Yes, what kind of star? Yes, Max.
A star. Wait,
Okay, Alice. What kind? You're muted.
I think it's a planet.
No, it looks like a planet. It's actually a blue subdwarf star. Now, Karina, why is it blue? Okay, so if it's blue, what does it mean?
It's
What does that blue mean?
young.
Is it called what?
Cool.
All right, so what does that blue stand for? If you see a blue star, what does that mean? Yes, Max.
It means that it is a star that is in the second life of the small star.
Okay, is it cold or is it burning really hot?
It is really, really cold.
Okay, but the blue means that it's really, really, really hot.
Yes.
Okay, so anytime you see a really, yes, Karina.
Wanted to say that it's very hot.
Okay, very good. All right, let's look at this one. What do you think this one is? What color is it? Max?
It is a red giant.
Yes, this one is actually a super giant. This is a super giant. Okay, so I actually have some more pictures that I want to show you about the telescope. But I want to tell you first about okay, so when you see stars twinkling at night, are they really twinkling?
No.
No. Okay, so if you look into the night sky and you see a yellow star and a blue white star, which one is hotter?
The blue one. The blue one.
The blue and the white one. Very good. Because small stars are generally red and yellow and are called dwarf stars. All right. So the small ones are dwarf and they're red and they're yellow. But some red stars are called red giants, like the one that we just saw. While the surface layers of red giants are relatively cool, they balloon up to a very large radius, and they emit huge amounts of light. So most of the stars in the universe are red dwarfs. Medium size, like our sun is a medium-sized yellow star. So it's just average, it's medium. The next largest stars are blue and white. These are called giants. So they make our sun look super small because they are so giant. And then the giant stars are very bright, but they turn to burn out fast. So they burn and then they don't survive very long. The largest stars are red and they're called supergiants. They can be up to 100,000 times brighter than our sun. So they would make our sun look very small and not very bright because it is so big and it is just so bright. All right. So did you know that there are some supergiant stars that are so big that they are as big as our solar system? Isn't that crazy? It's as big as our entire solar system, the Milky Way, the planets, everything. Yes, Max.
One of the stars that is not in our galaxy. It is big as our solar system. This name has 1B13.
Ooh.
Just in the short verse, because it has a really long name.
So could you find that with coordinates? Could you find it with your telescope?
I don't have a telescope.
All right, because I'm going to give you a website that you can go to see if you can find these.
Mhm. Thank you. You have frozen.
All right, so let me show you.
Let me show you what.
You have frozen again.
Yes. What?
All right, so I want to show you some more pictures of the telescope. All right. And then I want to show you also what a pulsar star is. All right, so stars do not last forever. Some of them burn really, really bright and then they disappear. And then sometimes they last for a while, like our sun has lasted for a long time. Eventually, the hydrogen that fuels and powers the nuclear reaction, so the gases that are in the star, they kind of start going smaller and smaller and smaller, and it phases out. So it expands and then cools, expands and then cool. And
And then mass.
You have frozen.
And then you're frozen. And then you are frozen. Oh,
What happened?
what
What happened? Why did you just disappeared?
all right, so it expands and then it cools. Then it expands and then it cools again. So what ends up happening is the small and medium-sized stars like our sun become white dwarfs, which disappear from sight once they have cooled. All right, a giant star turns into a red supergiant, and then it eventually explodes into a massive explosion called a supernova. And when it explodes, what does it do, Max? What does it do?
Turns in a pulsar.
That's right. And it starts pulsing and then it turns into a black hole. So let me show you what a pulsar, a red supergiant looks like. And
You have frozen again.
Yes, and again and again and again.
a red supergiant. This is what a red supergiant looks like. So what do you see? What do you think about this?
I saw that explosion.
It does. It looks like it's about to explode, doesn't it?
Yes.
Yes.
I think it just explodes.
Yes. All right. So let's go down. All right. So this is a view from the edge of the Milky Way. All right. Isn't that beautiful?
Yeah.
Yeah.
Except remember what we learned in the first lesson. It's very quiet and very dark in space. So they're not really shining because you have to have an object to reflect the light off of. So it's really not this bright in space. All right, so this is the remnant. This is a remnant of a supernova on the left, the purplish kind. and then the neutron star, which is a pulsar. Remember, it does this and then it explodes. All right. So which one? Now, what is a supernova again? I kind of forgot. Can you remind me? What's a supernova?
It's
It is an explosion.
Yes, it's an explosion. And then it turns into a black hole. And what is a black hole?
It's a hole that
it's a black.
has an end, but the end is really far from the, like, if you like would be in a black hole, you would just be like
Pancake.
All right, very good, Max. Yes. Now remember, they get the name pulsar from the
you have frozen.
Again. Why? Don't know. Frozen.
remember they get that the name pulsar from the act of pulsing. All right, and then it just explodes. All right, so I wanted to also tell you to show you these are the telescopes that are on top of a dormant volcano in Hawaii. What does dormant mean, Danya?
It's just sleeping and doesn't erupt anymore.
That's right. It's not dead. It's not extinct. It's not active. It could one day, but why do you think that they decided to put two huge telescopes on top of a volcano?
To see it better.
Yes, it's at the very
You have frozen again.
And again. And again. And again, 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 again. And again, again, again.
All right, can you see me?
Yes.
Yeah.
Okay. So when you're on top of this mountain or on top of this volcano, it's actually the tallest in the world because it starts growing at the bottom of the sea and it goes all the way up and it's the highest mountain. Well, it's a volcano. And then these are some images where they can see all the stars. So look at that light, and that light is looking out there, out into the sky.
Wow.
All right, so next week we are going to learn about constellations. So I will send you some new vocabulary and we'll have some fun looking at constellations. And you might have to remember to bring some marshmallows to class and toothpicks. Okay?
Okay.
All right. Well, I will see you next week.
Bye.
Bye.
Bye. Bye.
Thank you for the lesson.
Bye. 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 I'm Rose.